Welcome to the Explainer. Today, we're going to level up your Python skills by going way beyond the basic try except block. We're talking about how to build code that's not just functional, but truly robust and readable, using the power tools of exception handling, the else and finally clauses.
So, let's just jump right in with a question. We all use try and except. It's like a safety net for code that we know might break. But what about the other side of that coin? What about the code that should only run when everything goes perfectly right? How do you keep that success logic separate from the risky part of your code?
And that question, well, it leads us straight to our first big idea, using the else clause. It's designed for exactly this situation, handling the success path.
The rule here is super simple but really powerful. The code you stick inside the else block will only run if the try block finishes without hitting any errors at all. This isn't just about being tidy, it's about making the intent of your code totally clear. You're basically leaving a note for yourself and for anyone else who reads your code that says, hey, this part only happens when everything goes exactly as planned.
Okay, check out this example. What's so great about it is how cleanly it separates the jobs. The try block has one single risky task, turning user input into a number. That's it. If that fails, the except block catches the error, no problem. But the else block? It gets to do the victory lap, printing the successful result, but only after it gets the all clear from the try block. And you can see exactly how those two paths play out here. You type in 10, the try succeeds. Python completely skips over the except block and runs the else block. Boom, you get your output. But if you type 10, the try block immediately fails with a value error, Python jumps straight to the except block, and that else block, it never even gets a look in.
All right, let's add our next layer. So if else is for the sunny days when everything goes right, what about the things you have to do no matter what happens, rain or shine? Well, for that, we bring in the cleanup crew, the finally block. The most important word here is guarantee. The code inside a finally block is going to run, period. It runs if the try block worked, it runs if an exception was caught, and it even runs if some crazy uncaught exception's about to crash your whole program. This makes it absolutely essential for cleanup tasks, like closing a file or releasing a database connection. The kinds of things you absolutely cannot afford to forget.
So let's put them right next to each other. Think of it like this. Else is conditional. It's for the happy path. Finally is unconditional. It's for the always path. And understanding that simple difference is what lets you write code that's just incredibly reliable. One is for what happens when things go right, the other is for what must happen no matter what.
All right, now for the main event. Let's see how all four of these pieces, try, except, else, and finally, all fit together to create one single, totally bulletproof structure.
This little diagram just lays out the logic perfectly. Python always starts at step 1, in the try block. Now, if something goes wrong, it takes a detour to step 2, except. But if everything goes smoothly, it continues on to step 3, else. But look closely. No matter which of those two paths it takes, except or else, it always ends up at step 4, finally.
And this is where that full structure really starts to shine. We're handling two completely different potential problems here. A value error if the input isn't even a number, and a zero division error if the user enters 0. If, and only if, we manage to get past both of those potential traps, then we hit the else block to print our result. But the real magic is that finally block. No matter what happens, success, a value error, a division error, that last line, program completed, is guaranteed to print.
Okay, we've gone through all the pieces, we've seen how they work. Now let's put your understanding to the test with a scenario that's, well, a little bit trickier.
Whoa! Okay, take a close look at this one. We've got a nested situation here. A try except block living inside another try except block. Right in the middle, we intentionally trigger an error. The inner except block catches it, but then you see that little raise keyword? It immediately re-raises the error, basically throwing it over the wall to the outer block. So the question is, what actually happens next?
So put on your thinking caps for a second. Remembering all the rules we just covered, how except catches things, what raise does, and especially when finally runs, what lines do you think are actually going to get printed to the screen?
All right, pencils down. Here's the play-by-play. First, that value error is caught by the inner except, which prints inner catch. Simple enough. But then, raise passes that hot potato outward. The outer accept block catches it and prints outer catch. And because the finally block is always guaranteed to run at the very end of its structure, we get outer finally. And notice, both else blocks were completely ignored because there was never a moment of success.
So, what does this all mean for the code that you're going to write tomorrow? Let's boil all this down into a few key best practices for writing Python that's cleaner, clearer, and way more professional.
So let's just nail this down. The big takeaway is to use these blocks to tell a story with your code. Put your success logic, the stuff that happens when everything works, in the else block. That keeps your try block lean and mean, focused only on the risky operation. And always put your essential cleanup, like closing files, in a finally block to guarantee it runs. It's all about creating a clean separation of tasks, which makes your code so much easier for everyone to read and trust.
You know, mastering tools like this isn't just about learning some clever syntax. It's about building a stronger, more professional foundation for your skills as a developer. And as the great B.B. King said, that's the kind of knowledge that, once you have it, becomes a permanent part of your toolkit. Thanks for watching.